All right, I'll give you guys another 2 minutes. Don't worry about not finishing this. This was a tough quiz. Right, last 30 seconds to finish. And just starting today, for those of you guys online, can you guys, when you finish, submit it if you can? Like maybe take a photo quickly and submit it to thing. Can you guys do that, or is that too difficult? You guys don't have access to get scanned stuff.
I'm on laptop, so.
Oh, okay.
I'm on laptop too.
Oh, okay, yeah, okay, that's fine.
I'd rather just tell us you the answers on chat.
Yeah, sure, yeah, why not? Send it to me, the host account. I just want to keep track of the scores from now on. See how you guys are doing.
Is it the host one or just the normal one?
The host one. All right, we're done now. I will discuss anyway, so. Okay, I'll mark it. Just for now and for someone. I'll just keep track of the score. Which one do you mark? Black pen.
I've submitted all the answers on chat.
Okay, nice. Thank you. So
Me too, except for 3 and 8.
it's fine. All right. So. For the school. So don't be discouraged by low score. This is meant to be really highly time pressured because we don't have too much time here. So the thing is, I'm going to put the similar type of questions in the homework this week, so that once we go over it, it'll be easier for next week's homework. All right, so we'll discuss the quiz now. Let me just check. Give me 1 minute. I'll check it. Have everyone submitted all the answers?
I haven't.
Yeah, if you can, that would be great. I just want to keep track. And if you, for the ones you got wrong, go through them now. See, for those in class, see what you can do to fix it up. Okay, I'll go through those answers later. I'll pay out the scores later, but we'll discuss the quiz for now, right? Okay. So first one is the associative and commutative. Oh, I was doing it. This one, which is the associative and commutative property one. In this one, we're doing is we have -2304 minus 426 minus a -2304. This one's not as straightforward as the ones where you have positive, which is a bit more straightforward, but the idea is the same. So a lot of people, I think, the tricky bit here was thought that these ones don't cancel out because the negative sign makes it a bit trickier, right? But you have a negative and you're subtracting a negative from that. What does subtracting a negative do? If you do the definition, subtraction becomes this subtraction by negative becomes addition by
0.
no, not addition by 0 for this one, but addition by the positive version, right? Addition by its negation. And then you cancel them out. They have a negative and a positive. That together, they cancel. Which I can, full reason for it is like when we did the recap here. But I won't go through that fully. And look at the recap again if you want. And the only thing you're left with is the -426. So even though there's the two of the same signs, the subtraction makes it convert to positive, so they cancel out. All right, and then here, question 2, the key idea here was to see that they can be grouped. The grouping was, you can do 127 minus 27, group those two together. And the reason I can group it is if I can convert to an, should I show you the full working? Just because I want to show you how exactly it works. We can do it in one step like this, but I'll show you the work that takes you to that point. You can split it up like this. You get groups. 127 minus 27 is 100. 239 minus 39 is 200 plus 2348 minus 1948 equal to 400. So it's 100 plus 200 plus 400, which is 700. But do you guys know how to get to that? If you can do it directly with these 3 steps, that's all you need. But I'll also show you guys exactly if it doesn't make as much sense, I'll give you why that works. So actually, I'll write down top you can always use the new definition of subtraction, which is a minus b equals a plus negative b, or the negation of b, because that's very useful. What you do is you convert all the subtraction into addition. If you're not sure exactly how this works, that's plus negative 39 plus negative 27 plus negative 1948. Right, and when you do that, you can move them around. You can bring the 127 plus negative 297 together, plus 239. We have these two up together now because they have the same tens values, plus negative 39. Oh, sorry, 293, 239. Does it make sense why I'm doing that though? Why I'm pairing them together? Because they cancel and become like a nice hundreds number. 239 plus negative 39 plus 2348 plus negative 1948. Right, and then these are pairs. Pair here, pair here. The pairs will subtract like this. You end up with nice additions of 100, 200, 400, which is just 700. And that's our answer there. Okay, question 3. We'll go through that one as well. Anyone got any questions for the first two actually? Please ask me if you do. All right. On the next one, we have this, which is a bunch of like additions on the left side and then subtract by a bunch of additions on the right side. But obviously, if you do, and like I said before, long addition and long subtraction, all of that. So you can do it long addition and subtraction, but it'll be super long. That's why I didn't want you guys to do it that way. So here is the shortcut here. All right. Shortcut is just look at the pairs. What numbers pair up well here? So you have these positive numbers and you have subtract numbers you subtract from it. Is there any way that they'll pair nicely?
Yeah.
Yep. Which ones are they?
203 and 3, 200.
Yep.
109 and 9, 227 and 27, and so on.
Yeah. Does it make sense? When you do 203 minus 3, what do you get?
200.
200. And 206 minus 6 also ends up being 200. 209 minus 9, 200. You have a bunch of 200s. 209 minus 9 is 200. 220. And all the numbers in between also will pair up. 227 minus 20. Yep.
Could you do like 2 or 3 plus 230 would equal the same as 206 plus 227?
Or do the addition in there?
Yes, all of that.
That would work, but it'd just be a bit longer. But you have to, because then you have to do the addition, all the addition on the left side, and then do the additions on the right side and subtract that. But here you can just get all 200s, and that would just be easy numbers. So 209 minus 9 is 200. All the numbers in between have to be 200. How many of those pairs are there? So it's 3, 6, 9, keeps going, keeps going, keeps going. 27 and 30. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's 10 pairs, right? If you count carefully. It's like 3 to 30, so it's like 1 to 10, but everything's multiplied by 3. It's 10 numbers. Does that make sense why there's 10 numbers? Please ask me if it doesn't make sense to you why there's 10 numbers. 10 pairs here. All of these pairs add up to 200, so 200 times 10 is 2,000. All right. Now for the distributive property questions. Right, so for this one, I think one thing you gotta be careful is when you have common factor, you shouldn't cancel it out. You take it out and you multiply by it at the end. But you do the subtraction stuff, but you must still have to multiply by the end. So for question 4, I'll go through this one and then actually I'll go through 5. I won't go through 4. the answer to 4 is 290, and I'll explain 5, and hopefully it will make sense why the answer to 4 is 290 as well. Right. So for 5, what you need to realize is that there's a common factor of 84 in all of them. Right. So you can take that out as a common factor. Once you take that out, you do either 63 on the first one, there's 24 left on the second term here, plus 24, and there's minus 77 left, the third one. So you're just taking the distributive property for all of them. There's just been 84 times 63 plus 24 is 87, minus 77 is 10, so 84 times 10 ends up being 840. So don't forget about the 84, I think, sometime, right? And the same thing here, you just get 29 times 37 minus 27, which is 29 times 10, just 290. Same logic here. And then 6, I'm not going to show the full working, I'm going to go to this step. We take out 82 out. And you get times by whatever the numbers add together, adding 99, right? You do all addition and subtraction, you get up to 99. Here's where you got to be careful. Right? 82 times 100 minus 1 is the trick to go from. Since I said no long multiplication allowed, here's the trick. It's 82 times 100 minus 1. So 82 times 100 is
8200.
You just add 2 zeros. And minus 82 times 1. Minus 82. You can just subtract this if you want, but you can do this in one step, right? It's pretty simple. 401. That's 10. That's 10. That's 9. 10 minus 2 is 8. 9 minus 8 is 1. This became 1. That's 1. 8, 1, 1, 8. But the reason how I got to this step is by whatever I did, same thing as I did in question 5. There's no difference. The difference between 5 and 6 is once you get to here, you can do the distributive property again to get into nice multiplications. Okay. Question 7. I know you don't need a diagram, but it is always useful if it gets tricky to use a diagram as well. This is 136 miles, right? Start at 0. You go 15 to the gas station, right? Then you go another 23 to lunch. But then you backtrack, so you go back by 2 miles. So you went 50 plus 23 minus 2, which is 36 miles. What you have left is 136 minus 36, which is 100. All right. We're running out of time, but we'll quickly go through 8. This is a really tricky one. Right, so for 8, the trick here is that so before you know how here in this question, in question 3, they were all in nice order. The first one pairs with the first one, second one pairs with the second one, and so forth. The trick here is that they don't pair like that. What happens is the first one pairs with the last one. Second one pairs with the second last one. The third one pairs with the third last one. So you gotta just try to come up with pairs, but if you go from left to right, they don't pair nicely because you get negatives here. So if you do the opposite way though, first one is the last one and so forth, you realize this one minus this one, it's 80. This one minus this one is 80. This one minus this one is 80. So you have, and the 400 minus 320 is 80. 390 minus 318 is 80 as well. A bunch of pairs that add up, the subtract up and have a difference of 80. How many of those pairs are there is the question. So it goes from 300 to all the way to 400. So 2, 4, 6, 8, 10, all the way to 100 basically. How many pairs is that?
Maybe
Don't necessarily guess. You can think of like, it's all the even numbers from 0 to 100 or 1 to 100, right? There's 100 total numbers from 1 to 100. How many even numbers are there?
50, maybe.
Exactly half, right? Half odd, half even. Half of 100 is 50. It's 50 pairs. 8 times 50 pairs. And that's whatever. Can you guys do this without long multiplication? Do you know the trick to this? What you do is you do,
You do 8 times 5.
yeah,
which is 40,
yep,
and then add 2 zeros.
exactly. That's the answer. Do 8 times 5, which is 40, then you add these two zeros. That's how you do that. And that's question 2, the last question. All right, finish there for that. Now we'll move to today's content. So this section is a tricky section, right? So I will upload more homework questions for this week's homework as well, related to this stuff. Also, I just want to say, for today's class, I'm using a slightly updated handout. It's basically the same. There's a few examples that are different, so it won't be exactly the same as your handout. But don't worry, it's not going to make that much of a difference. If you're online and you want to access this, I put it up as well, but you don't need to. It's basically the same thing as the other handout anyway. All right, so by the way, did anyone have any other questions with the quiz before we move on? Nope. Okay. All right, so we'll do the new topic, which is reciprocals. First thing I want to do is, okay, has everyone got the handout for this one?
Yes. Mine's a bit different.
Yeah, it's a
Yes.
bit different. I'll show you the what page it is on the second handout.
I think it's 12.
I have it.
Yeah, page 12 on your handout. But on, yeah, this is slightly different notion I've got because it's slightly updated, but. All right, so here's the idea for the reciprocal. So we have this thing in for addition, we have 0, which is a special number, because whenever you add 10, any number to 0, what does happens? Just change the number. If you add 2 plus 0, that's 2, 5 plus 0 is 5. So whenever you add some number plus 0, it doesn't change. So 10 plus 0 is always going to stay as 10. So when we come up with the idea of negation, when we cancel out a number, we did what number do you need to add to like 10 to get back to 0, right? And that was, yeah, negative 10. What's the negation of 10? Right? What's the negation of negative 10? What number do you need to add to negative 10 to get to 0?
10. Positive 10.
Positive 10. So that's the idea of negation. So we're going to do this very similar thing with multiplication as well. So 0 is called the addition identity, sorry. Identity is a very common term in math. Identity means it's an operation, it's a special type of like number or whatever that doesn't change the value. So whenever you have addition, you add 0, it doesn't change it. Then just like that, 1 is a multiplication identity. Whenever you multiply a number by 1, the answers to that are gonna stay the same. 2 times 1 is? 1,000,000 times 1 is? 1,000,000, right? It doesn't change. Times 1, so 10 times 1 is 10. The idea for reciprocal comes from which number do you need to multiply 10 by to get back to the identity, which is 1. Right? So is this number, let's put a little question mark on it. Is this question mark number, can it be a whole number? All right, because every whole number you multiply. But if you multiply by a whole number, like 10 times 1 is smallest positive whole number, right? If you do 10 times 1, you're going to get 10. I'll say a thing on number line. 0, 1. 10 times 0 is 0, so that's here. 10 times 1 will get you to 10, but we want to get to 1. So the number we want is somewhere between 0 and 1, which is clearly not enough, right? So we need to come up, which is clearly not a whole number. So to come up with this, what we do is we create a new number, which is called a reciprocal. All we do is put a 1 over the number, 1 over 10. It's like a fraction. Looks like a fraction. It is a fraction, but it's a special type of fraction. It's called a reciprocal.
Does 0 count as a whole number?
It depends, to be honest. Like some people say yes, some people say no, some people say yes. It's not that big of a deal to know whether it's a whole number or not, to be honest. It's a subjective thing.
Okay.
Right? So the reciprocal of 10 is this idea of 1 and 10. Right? This new number. But how big do you guys think 1 and 10 is?
0.1.
As a decimal, yes, but Oh, you got it in decimal, so that's fine. So it's exactly 1/10 of the gap between 0 and 1. It's exactly like if you divide this gap into 10 equal parts, you can get 1/10. And this is 1/10. It's close to 0 like here. Right? And you multiply 10 by that number and you get 1. Right? This definition is really important. This is the definition we're going to use. 10 times 1 on 10 is 1. In general, for any number A, if you multiply by its reciprocal, you're going to get back to 1.
A mean?
If any number A, like A could be any number, it could be 1, 2, 3, 4, 5, 6. It could be negative even.
Yeah.
If you multiply by its reciprocal, you get back to 1. This is the important definition. Now let's go watch a short video to get an idea for this. Okay. All right, so this will tell you what you should do.
At Valia, we know a healthy gut means a happy you. Our deliciously creamy probiotic yogurt is proven to naturally boost digestion and immunity. Valia, get gut happy.
Can you guys online hear that? Did you hear the ad before?
Yeah.
Yes.
Eight plus 0 is 8, because that's what 0 is. 0 is defined as the number that if you take some other number and add it to 0, you get that other number back. So 8 plus 0 is 8, and for that reason we have a special name for 0. We call it the identity of addition. Now then we come to this question, what do I add to 8 in order to get back to the identity, in order to get to 0? Well, to answer that question, we made up a whole new kind of number. We made up negative numbers. And we put the negation of 8, negative 8, right in here. And we define that as the number that we have to add to 8 in order to get back to 0. Now, moving on to multiplication, the identity of multiplication is 1, because if I multiply 1 times any other number, I get that other number. So 8 times 1 is 8. Now, what do I multiply 8 by in order to get back to 1? Well, for addition, we had to make up a whole new number in order to figure out 8 plus what equals the identity 0. Well, down here in multiplication, we're going to do the same thing. We're going to make up a whole new number, because that's sometimes what we do in math. When we have a question that we can't find an answer to, that we don't have any sort of number that can fit in this box, we certainly can't put any integers in here. You put in 0, you get 0. 8 times 0 is 0. 8 times 1 is 8. 8 times 2, 8 times 3, all those numbers are going to be higher than 1. 8 times a negative number is a negative number. So we need a new kind of number to go in here. So we are going to make it up. That's right. We're just going to make it up and see what happens. We're going to call this number a reciprocal. And here's how we write it. We write it as 1 over 8. Now you probably recognize this. Looks like a fraction. You've probably seen fractions before. And reciprocal, this is a fraction. It's a very special fraction here. 1 over 8 is the number that we multiply 8 by in order to get 1. And that's how we define this number. Now you might be wondering, how big is this number? It's obviously not negative, because if you multiply 8 by a negative number, you'll get something negative. And 8 times 0 is 0. 8 times 1 is 8. 1 is between 0 and 8. So we figure this 1 over 8 number, that's somewhere between 0 and 1. And it is. If you were to draw a number line, this 1 over 8 number is between 0 and 1, and it's closer to 0. It's right over here. So this is a real number. We can find it right here on the number line. But we've totally made this number up just to answer this question of 8 times what equals 1. And the answer to that question, 1 over 8, is the reciprocal of 8. Now, that's enough about 8. Right? We can do this with any other number. The reciprocal of, well, maybe almost any other number. Let's see. Can we find reciprocals of other numbers? 2. The reciprocal of 2 is 1 over 2. Let's try 1. What's the reciprocal of 1? 1 times what equal? 1 times 1 equals 1. The reciprocal of 1 is 1. All right, easy enough. Let's try another one. The reciprocal of 1, what?
What do you guys think this is going to be? What do you multiply 1 over 8 by to get to 1?
8. 1 over
8.
Right, it's opposite. You need to multiply 8 by 1 over 8 to get 1. Or we multiply 1 over 8 by 8 to get 1. So that's
-8.
it's positive 8. And you'll see
That is a reciprocal. So we have to find a reciprocal of a reciprocal. What do I multiply 1 over 8 by to get 1? But we just defined 1 over 8 as the number you multiply 8 by in order to get 1. So 1 over 8 times 8 is 1. That's how we defined this number. So the reciprocal of 1 over 8 must just be 8. So the reciprocal of a number, you get the number back. All right, good enough. How about negative numbers? What's the reciprocal of negative 8? Well,
what do you guys think this is going to be? Reciprocal of 8 is 1 over 8.
Actually, no.
No. Oh, no.
This negative 8 is the same as 8, except the sign's different, right? Only different sign. You're going to get back.
Negative 1 over 8.
Yeah, but
-8. -1 over 8.
because you can multiply, when you have 8, you can multiply by 1 over 8 to get 1. If you have negative 8, you want to get back to positive, you're going to multiply by negative 1 over 8. So it's negative 1 over 8.
the reciprocal has to be negative because I've got a negative here. If I multiply negative times a positive, I'll get a negative number, not 1. So I figured the reciprocal is going to be negative, but what is it? I would know what to do here if this were a positive number. If we just had 8, we know that the reciprocal of 8 is just 1 over 8. So by definition, that's 1. So let's see what happens here if I multiply negative 8 by the negation of this, by the negative of 1 over 8. Well, I know how to do that. I know how to multiply two negative numbers. You multiply two negative numbers, you get the same thing as if you multiplied their positives. Ah! 8 times 1 over 8, that's just 1. So I know that negative 8 times negative 1 over 8 is 1. So I know what goes in this box. The reciprocal of negative 8 is just negative 1 over 8. All right, so we know how to deal with negatives. We know how to deal with the reciprocal of a reciprocal. We know how to deal with 1. How about 0? So we take 0 and... Wait a second. If I
Does 0 have reciprocal? No, right? Because you multiply a 0, you can never get 0. You're never going to get to 1. So 0 doesn't have reciprocal.
You cannot get to 1 because like 0 is like a number.
Yeah.
It's the portal of the negatives and the positives.
Yeah. And if you multiply a number 0, you're going to get back to 0, so you can never get to 1, right?
multiply anything by 0, I get 0. It doesn't matter what I put in this box. I'm always going to get 0 out. I can never get 1 out. We can't take the reciprocal of 0. There are very few rules in math about what you can't do. This is one of them. You can't take the reciprocal of 0. And go ahead and try it. Bad things happen if you take the reciprocal of 0. Try it. You're still here. You didn't take the reciprocal of 0, right? You didn't do it because you wouldn't be here if you did. Bad things happen. You can't take the reciprocal of 0. All right, so repeat after me. Is one rule about what you can't do. I will not take the reciprocal of 0. I didn't hear you. A little louder. I will not take the reciprocal of 0. All right, that's good. Let's recap. No reciprocal of 0. So what we did here was we made up a whole new number, the reciprocal, just to answer this question. What do I multiply a number by in order to get 1? The number's reciprocal. Now if we look back to addition, we made up these negatives, made up negation in order to answer this question. And then we use that negation to define subtraction. So if you add a negation, you get subtraction. So what do you think we're going to do down here with multiplication? We start with a number, we multiply by a reciprocal. Adding negation gives you subtraction. Multiplying by a reciprocal, you got it. That's what's coming up next. division.
So this idea of reciprocal we're going to use for division later. For a little bit, not for all division. Right? Okay, so hopefully that video made it reciprocal idea a bit clear. I'm going to do a few questions with it, right? So I want you guys to find the reciprocal of the following numbers here. I'll give you guys about 3 minutes or so to do this one.
So for the chat, so do we send it to you in the host one or just the one that doesn't say host?
The host one, yeah. All right. Let's take a look. Okay. So the reciprocal of 7, right? This one's like the normal numbers, just 1 over whatever that number is, right? 1 over 7. Reciprocal of this huge number here, it's just 1 over that number. 1 over 3, 4, 4, 5, 4, 3, 4. The reciprocal of number A is just 1 over that number A. Right? So the first 3 just do 1 over whatever that number is. The next one's a little bit trickier ones. The reciprocal of negative 12. It's just 1 over 12, but because it's a negative, you're going to multiply by a negative number. So it's negative 1 over 12. So the reciprocal of negative is just the reciprocal of number, but you put a negative sign. Because remember, if you do 12 times 1 over 12, you get 1. That means if you do the negative versions, you're going to get back to 1 because negative times negative is positive. So you can't have a positive number here because if you get back to a positive number, you're going to multiply negative by a negative. So the reciprocal that is negative 1 and 12. What's the reciprocal of 12 times 3? Yep. Yeah, perfect. Because 12 times 3 is 36. You find 36 first, then you do the reciprocal of that, which is 1 over 36. Right? And what's the reciprocal of 1 on 8? Yeah, but very good, Sarah. It's a tricky one. Sarah,
A.
and what is that?
Is it A? Because in question C, it says A equals 1 over A. So that's
Exactly.
pretty much the same thing.
A times 1 on A is 1. So the number you multiply by A to get to 1 is 1 on A, but the number you multiply by 1 on A to get to 1 is just different because you switch the order, and then you just put A here. I mean, multiplication is commutative, so it's just 1 on A times A, same as A times 1 on A. So that's that. And the answer to this one is A. All right. We'll finish these two last ones, and then we'll go through, I'll let you guys do this one by yourself, first one, and we'll discuss the third one together. So can you guys spend 2 minutes doing this exercise here? Exercise 1.5.2. Okay, first of all, if I ask you what's the product of a number and its reciprocal, what's that going to be? Product means multiplication, the answer when you multiply. If you multiply a number by its reciprocal, you get back. What's the definition? If I multiply number A by its reciprocal 1 on A, what am I going to get back? Not exactly 1 on 10. Now we're not just finding the reciprocal, we're doing multiplying the reciprocal by the number. What's that going to be? It's going to be 1, right? That's the definition. But the question is slightly different. It's not A times 1 on A, it's A times twice the reciprocal. It's basically A times 2 times 1 on A. How's that going to be? A times 1 on A is 1. A times 2 times 1 on A going to be?
B.
2. Because if you rearrange this, A times 1 on A times 2, A times 1 on A ends up being 1. This part, these two cancel out to be 1. And the 2 is remain. 1 times 2 is 2. So the answer to this one is 2. So this definition is really important. Keep this definition in mind. Multiply a number by its reciprocal, you're going to get back 1. Okay? All right. The second one is explain why the reciprocal of 5 times 7 is 1 and 5 times 1 and 6. Okay, first of all, what is the reciprocal of 5 times 7? 35.
1 over 35.
Yeah. 1 over 35, right? Because 5 times 7 is 35. Reciprocal, that is 1 and 35. But we're trying to show that this is equal to 1 and 5. So we have 1 and 5 times 1 and 7 here. How are we going to show that they're equal? Right? And one way you can do it is you can just do like fraction multiplication. 5 times 7, multiply the denominators together. You 1 and 35. But that's not exactly a proof. Right?
Like the equal fraction.
Yeah, the equal fraction, that means they're the same. Yes, I agree. Right? So that's one way to show it. But let's pretend we can't do fraction multiplication. We know how to do it. What if you do this? 5 times 7 has 1 on 5 and 1 on 7. If this is the this one is the reciprocal of this number, the blue number, then this should equal 1, right? So you can prove that it's 1, then we've done it. What I do is, with this multiplication, I can rearrange these two. I can switch these two. 5 times 1 on 5 times 7 times 1 on 7. Right? What's 5 times 1 on 5? This pair first, 5 times 1 on 5 is going to be? No, it's 5 multiplied by its reciprocal. Any number multiplied by its reciprocal is going to equal but you multiply by its reciprocal, you get back to. Remember the definition of reciprocal? Very important. No. What's the special number for multiple? 1. That's 1, right? 5 times 1 and 5 is 1. 7 times 1 and 7 is going to be 1. Always when you multiply two numbers by its reciprocal, you get back 1. This ends up being 1. So that means that 1 is the reciprocal of blue. That's another way to prove it. But this is the easier way, the fraction way. Right? But we won't talk about fractions yet. We'll go into fractions later, but we'll go in more in depth than school. Right? So does that make sense? How we show that it's the reciprocals? Yep. What about you guys online?
Don't really understand.
So what we
I
did was,
understand.
so if you don't understand, that's fine. So I'll explain that again. But so the key idea here is, because multiplication can switch it around, right? Actually, first of all, does the fraction explanation make sense?
Yeah.
So fraction one's pretty simple because we know fractions already. I'm using it. Another way to explain this is, if these two, like if this pink bracket is a reciprocal of the blue brackets, right? A pink number in the, but on top of the pink, if they're reciprocals and you multiply them together, what do you get back?
1.
1. So if we can show that they multiply together to 1, we show them they're reciprocals, right? That's what we did. First what we did is we rearranged multiplication. And we switched these 7 and 1/5, because with multiplication it's commutative, right? When you switch them, you get 5 times 1/5 times 7 times 1/7, right? And 1/5 is the reciprocal of 5, and 1/7 is the reciprocal of 7. So when you multiply 5 by its reciprocal, you get back what?
1.
1, because that's what definition. So I know definitions are weird, but you just have to trust the definition, right? So when you multiply 5 by its reciprocal, you get back to 1. When you multiply 7 by its reciprocal, you get back to 1. So these two multiply together to get to 1. These two multiply together to get to 1. So you end up just getting 1 times 1, which is just 1. That means this original term is also reciprocals. Does that make sense?
Yes.
So it's a bit weird, but they're using the definition. Right? So we'll have a break now for 5 minutes, and then we'll come back and move on. Yep, sure. Go for it.
You do the maths online thing.
That's online thing. I've looked at it. I'll try to implement. I've been a bit busy. I'll try to do it soon if I can.
Okay.
What do you think Geelong's going to make the 8? No? They've got a shot. They have Saints, which I hope they should win against.
Who?
They're playing Saints tonight, isn't they? St Kilda.
Really?
Yeah.
But we had our last game against Melbourne.
No, it's Bulldogs next week against. If it's against Melbourne, we'll lose. That makes sense, but
Oh, wait, what?
Imagine being 11 to the water.
Well, you guys aren't in the 8 anyway.
We might be today. We're versing Giants today.
But you're playing Collingwood next week, so.
Yeah. We might lose in that one.
I feel like it's better than might. Better chance than might.
Yeah. But they lost to Hawthorn, but there's like a chance. They lost to Hawthorn. That's like one of the worst teams.
Who lost to Hawthorn?
Collingwood.
Oh, that's a while back. Like 3-4 weeks back. Though.
Yeah, but still.
Yeah. Okay. If you guys win, but obviously you're in.
We're like a little bit off from Western Bulldogs to get in the top 8.
Yeah. Who are the doggies playing?
Isn't
I
it?
think the West Coast.
West Coast, yeah.
That's so free.
That's like a free win.
Yeah.
But it's probably better than
And they're not that good anymore. Though.
yeah, no, they wasted all of it.
Yeah.
At the start of the year.
I think Brisbane might win. Okay. So we'll get started again. So now we're going to do reciprocals of special numbers. So reciprocals of negative, and stuff like that. So the first idea here is reciprocal of reciprocal, right? So you remember, if you do the reciprocal of 10 is what? Yeah, so that means when you multiply 10 by 1/10, what do you get back? 1. That's a definition. So this is a definition. So another thing is definitions are, there's no reason for definition. That's just how they're defined. So they're going to feel a bit unusual for you. So trust the definition for it, and then you'll get used to it after a while. So there's no reason for that. There's no way to explain definitions. So they just, someone defined it that way, and you just have to accept it. Right? So I can't really give you a reason for it. So you just have to trust the definition for a little bit, and it will become instinctive a bit later. All right? So we know that 10 times 1/10 is what? What number do you need to multiply by 1/10 to get to 1?
Can I go to toilet?
Yep, sure, go for it. Yep, and Sarah said the answer here, it's 10. So very good. Because 10 times 1/10 is 1, 1/10 times 10, the same thing, you just reordered them. And it doesn't change the value when you reorder multiplication. So it's just 1. So the number you need by 1/10 multiplied by 1/10 to get to 1 is 10. That means the reciprocal of 1/10 is 10, right? That's the definition. The number you multiply by 1/10 to get to 1 is 10. The reciprocal of 1/10 is 10. Yep, sure, Sam. All right, so now, by the way, if you guys want to go to the bathroom, you don't have to ask me. All right, so you can let me know if you want to, if I ask a question, but that is fine. So by in general, though, the reciprocal of a reciprocal is what? What do you need to multiply by a reciprocal to get to 1? No, what's the reciprocal of 1/20? Yeah, so the reciprocal is the original number. That's the concept. Does that sort of make sense? Yeah. So it comes back again. So that the reciprocal of 10 will be 1/10, but the reciprocal of that one will be 10. Reciprocal of 27 would be 1/27. the reciprocal of 127 will be come back to the start, which is 27. So that idea is important for the next few questions. Can you guys do these 5 examples here, 5 questions here? Give you guys about 2-3 minutes. We need to find the reciprocal of these numbers. But just use this concept where it's just the reciprocal of reciprocal is the original number. Be careful. It's not 108. If you can try to get the fraction to have the top number be 1, then you can reciprocal. So again, I think that one's part C is going to be careful. Yeah, so I'm trying to simplify the fraction so that it has 1 on top. Then do the reciprocal of that. Yeah, that was the reciprocal of that. Because that's what it equals, right? It's the reciprocal of that. That's it. So if you guys, so your first 2 answers are good. Sorry, my bad. So what's the reciprocal of 1 and 13?
13.
Yeah, I wrote that down accidentally, so it is 13. But why is it 13?
Because it's the opposite.
Yeah, and it's the original number again, right? The original 13, 1 over 13 is the reciprocal of 13. So the reciprocal of reciprocal comes back to 13. The same thing with B, reciprocal of 1 and 17 is 17. I'm going to skip C for now, but that's a tricky one. I'll come back to it at the end. Right, so this is the difficult one. What's the reciprocal of 1 on X? Yep, Emma? Yep, it's X. You go back to the original number, which is X. And what's the reciprocal of 1 on 4 times 1 on 7?
I times 18 by 3.
That is tricky. It's not exactly that. It's not that. It's a bit more tricky than that. Yep, Emma, what's E?
1 over 20.
What's the reciprocal there?
20.
28. 1 on 4 times 1 on 7 is 1 on 28. The reciprocal would be 28. Right, so does that make sense? Now we're going to discuss C. So C is the tricky one, and there's a little trick to it. So some people got the answer 54, which isn't what we need. It's not, you can't do reciprocal and be like, it's 18 times 3. There's no, I know it seems like just multiply the numbers together. That seems pretty intuitive, but it's not the way to go about this. What you want to do for reciprocals is to get this fraction to have the top number be 1. So you want to simplify the fraction down.
Be 6 if I see.
Sorry?
Would the answer be 6?
Yeah, the answer is 6 because this is equal to 1 on 6, right? You simplify the fraction first. Right? So 300.
In 5 more minutes.
Sorry?
I need
Oh,
to
yeah.
above the class in 5 more minutes.
If the class is recording, so I'll upload it up and you can see
Yeah.
the rest. It's not 54, by the way, so I'll put it in red actually. You simplify the fraction down to become till it becomes 1 over 6, right? And then what's the reciprocal of 1 on 6? 6. That's 6.
6.
Yep. And that's the answer there. Now, what about reciprocal of negative numbers? The reciprocal of 10. Sorry?
Isn't it like positive numbers? Or
No.
negative fractions?
Yes, exactly. Because remember, when you have
Yesterday, when I was doing alchemist, I thought the homework was doing reciprocal, so I did that.
that's good. You're ahead then. Wait,
I got a lot of right.
that's really good. Can you join my classroom on Alchemist? Then I can see how you're going with the questions. I'll send your mom the link if you want. We'll figure that out later, don't worry. So, okay, because Alchemist is really good practice. I was saying, get back to what we were doing before. The reciprocal of -10 is going to, so the reciprocal of 10 is 1/10, right? We've talked about that a lot now. The reciprocal of -10 is going to be -1/10. And the reason for that is, this idea is really important. When you multiply negative by negative, you get the positive version. So -a times -b is just +a times +b, because the negatives cancel out. So we have -10. To cancel all the negatives, you multiply by another negative number, which is negative of the original reciprocal of 10. So negative of 1/10. So -1/10, get back to 1. Does the idea make sense? Because you're going to cancel out the negatives, so you multiply the negative number by another negative. Other than that, the number values stay the same. Now we're going to use this idea to do the next, these 6 questions here. Is it the same for you guys, or do you have these 6? All right. We'll do this question. Exercise 1.5.4. Let me check. How it's different. Oh, the same on your. So page 14, your handout. So it's 1.5.4. Oh wow, letters are horrible. It's E. I should have put E and F. I was B and C. My bad. Those 4 are all good. I didn't say your words. I did the way I formatted the letters.
Oh.
Yeah, no. I put A, B, C, D, and then B, C again. Why so painful? Yeah. You must probably shoot it up and leave. Yeah, perfect. So that's -1/24. Reciprocal that is -24. Say your first 3 are correct. So what's the reciprocal of -7? Yep, Emma. Yep, all right. Now I want someone online to answer the next one. What's the reciprocal of -3, 4, 4, 5, 4, 3, 4?
-1 over.
That number, right?
Yeah.
Yeah. Good. What's the reciprocal of -a? Anyone for now on this? Yep.
-1 over.
Yeah, very good, Ryan. And D. What is the reciprocal of -1 and 13? Ima? Yeah, -13. Very good. And I should. Sorry.
I need to go now.
Oh, okay. Good luck. You have karate, right?
Yep.
Good luck on it. Bye.
Thank you. Bye.
All right. So E. Right, what's the reciprocal of this number? This is a highly tricky one. Yep, Imal? Yep. It's negative 24, but why is it negative 24? Another question.
6 times 4 is 24.
Yep. But it's a negative 1 and 4, right?
Yes.
So when you multiply these two together, what do you get? 6 times a negative quarter, a negative 1 and 4.
Negative 24.
1 over 24, right? Just the
No,
answer.
24.
Yeah, but when you do the reciprocal of this, you get negative 24. But when you just multiply these two together, you get negative 1 and 24. Does this part make sense to everyone?
Yeah,
All right, good.
it makes sense.
And then and after that, find the reciprocal, not too hard, right? You just do the reciprocal of negative 1 and 24, which is negative 24. Right? And finally, what's the reciprocal of negative 1 on b? Yep, good. Can anyone, I just want to check online people as well. How'd you guys go with that? What'd you guys get? Negative b? Yeah, good. Okay, now, what's the reciprocal of 0? Like we saw in the video, what's the reciprocal of 0?
Nothing.
Nothing, it doesn't exist. So big 0 times something is 0. But we know that multiplying 0 by any number will equal to 0. So we know that 0 can't have a reciprocal. No reciprocal. And actually 0 is the only number without a reciprocal. Every single other number has a reciprocal. This is important. Okay, so we'll take a couple minutes just to refresh after that. But all right, so now we're going to go to a new idea, which is multiplying reciprocals. Right, so whenever we need to multiply whole numbers and reciprocals, or reciprocals by reciprocals, the easiest way, especially if we're going to do whole numbers by reciprocal, the easiest way is to cancel any factors, the reciprocal out first, so that the overall multiplication ends up being as easy as possible. So I'll explain what I mean by that. So what I mean by cancel the reciprocal out first is this. Look at the example, right? So 10 times half, right? What do you think first of all, what do you think that's going to be? Not sure. So we should use a definition or try to use a definition at all times. So we know that what's the reciprocal of half? So 2 times half is going to be 1. We know that, right? So if we can find a factor of 2 within this 10, we can separate the 10 into like 2 times something, and we can do it that way. And I'll show you why that's equal. 10 is equal to 2 times what? 2 times? Reason I want to do this, right? So now what we do is we see that when you do 2 times half, what happens to these two? So that's not exactly the answer, no. No, that's not, we're not trying to find the reciprocal of 10. We're trying to just do 10 times half, right? What's 2 times half? It's what? Sorry?
Oh, 3.
No, 2 times half. It's 2 multiplied by reciprocal. What's that going to be? 1. That's a definition, right? I can rearrange it to make it easier for you guys to see. 2 times half times 5. But these two will always multiply to 1 because their definition. That's the definition of reciprocal. So 2 times half is 1. It ends up just being 1 times 5. 1 times 5 is just 5. Yep, so that's
1 times 5 is 5.
Yep. Does that make sense? We split it up like this to get the reciprocal here so that we can cancel it out. Does the idea make sense? So when you do
Makes sense now.
yeah, but we're gonna do it now. So later on, again and again, it'll become more common, make more sense. Now we're gonna try to do the similar thing with b as well. It should do 165 times negative 111, right? So you want what's the reciprocal of negative 111 to begin with? Negative 11. We want to take our negative 11 as a factor. What number do you need to multiply by negative 11 to get to negative 160 to get to positive 165? We know that's going to be negative. What's the negative value? You can divide over 165 divided by 11. No, it's going to be 160. What? 11 times by number is 165. What's that going to be? You can
1.
do, no, 11 times 1 is 11. 11 times something is 165. Okay, negative, yeah. But it's negative 15 because it's negative 11 times, right? Times by negative 111. What does this end up being? I'll get a reference. I don't know why I put the brackets there. Right? What happens to these two? When you multiply them together, what do you get? Negative 11 times negative 111 is going to be? Someone online? Sorry? Negative 11 times negative 111. They're reciprocals, right? Yeah. And if you multiply reciprocals, you get back? One. Right? Because the reciprocal number multiplied by reciprocal is 1. This idea makes it a very tricky idea. If you just want to get the reciprocal here so that you can cancel it out, basically. Cancels out with the reciprocal. And it just ends up being negative 15 only. 1 times negative 15, just negative 15. Does that make sense? Okay, sometimes you can't do this though. The first, you could just take out the reciprocal as a factor, right? But sometimes when you do three, let's say, for example, 3 times 1 and 5, right? What's the reciprocal of 1/5? 5, right? So it's 5. It's good. But is 5 a factor of 3? No, right? 5 is bigger than 3. You can't possibly be a factor. Then you can't do anything. Here you can't do anything. You just leave it. Just go 3 times 1 and 5. I'll just put the 3 up the top, 3/5. So you can do that. You can multiply the top part by the top part. Right? This is fraction multiplication. We'll go into in-depth into fractions more later. Also, are you doing alchemist?
No, I found this on Alchemist. I want to try and see if we can do it.
If I can do it.
Yes.
Okay, we'll do it. I'll do it after. I'll do it next. All right. Okay. So last one is D. 1/7 times 1/2. Right? It's 1 and 14. Oh, what I said that? Oh my god. I said that accidentally, that's my bad. But okay, I accidentally said 1 and 14. But why is it that? Yep.
It's maybe. Oh,
Yep, go ahead.
it's 1 over 14 because 1 times 1 is 1 and 7 times 2 is 14.
Yeah, you multiply the top part by top part with 1. And the denominators by the thing, 7 times 2 is 14. That's this idea is these are not as important right now. We're going to talk about this more in detail in fractions. But it's 1 14. So I'll try your problem a bit later. Let's just quickly finish this part out, and then when we'll do the examples, I'll explain that answer one. All right?
Go to the,
Sorry?
go to the table.
Yeah, sure. So whenever we'll just finish the fill in the blanks first. Whenever we can't cancel the reciprocal fully, we end up forming a what? What do we get here in C and D when we couldn't cancel the reciprocal properly? We end up forming a these numbers are, what are they?
Fraction.
Fractions, right? We'll learn about fractions in very much more detail later in this class. I think probably end of this year, towards end of the year, to those type of things. Right, so the reason we're going to tell this slowly, but I want to go into it much deeper than what you do in school. So I want you to understand it fully. All right, so yeah, we'll do exercise 1.5.5, and I'll try to do your question while you go through that question. All right, so I'll do the question you sent me, but for everyone else, and Sarah included, do exercise 1.5.5.
Okay.
Is that already checking that, right? I mean, it's good that you want to like please tell me the answer, but sometimes I'll just ask the online people just because I don't like get to see the interaction. Is that fine?
Yeah.
Just 'cause you can already check the answers and everything. Don't feel like if I'm trying to like ignoring answers. No, it's just that I already know that you. Oh, sorry, is it different? Yeah, do the ones on the screen just because they're a bit easier. These are a bit big. Sorry, so the one on the screen's different. So could you do those ones? They're a bit easier. I think I felt the numbers are a bit big before. There's a few more later, but yeah. Actually, I'll write them out. Yeah, this page. I think you don't have them on your one. Put them at the bottom of the screen. Half and F is 5 times a quarter. 6 parts to this. So do the ones on the screen, please, just because they're a bit easier. I feel like the other numbers are a bit big. Say, is the answer to your question 1? What are the 2 fractions there? Because the one you sent me is like weird formatting. And you might do on paper.
No.
Good. I just think the reciprocal 1 and 8 plus. And on multiply and split it into 8 times something. That's the idea we did the previous question. So you gotta be careful here. You're not doing reciprocals. You're doing multiplication, right? 17 to 1 and 8. What you do is you want to find the reciprocal of 1 and 8, which is 8, right? So we split this up into 8 times something. 8 times what is 72? 8 times 9. Then when you got 8 times 1, 8, they cancel. The only thing left with this. So write it up like this. I'll show you part A again. So part A is tricky. So you wanna cancel this 1 and 8, right? The way to cancel the 1 and 8 is to get multiplied by its reciprocal, because then you get to 1. That's the reason for it, right? So you want to get some 8 within the 72. Rex, put the 72 up into 8 times something. 72 is 8 times what? 9. So 8 times 9 is 72. And then you left multiply that by 1 and 8. And the reason we do that is because when you multiply 8 by 1 and 8, what do you get? It's 8 by its reciprocal.
1.
1. So instead of just being this to cancel up to end up being 1. So 1 times 9 is 9. That's the point of doing that. Because when you get 8, you can cancel it out. That's why it doesn't work if 8 is not a factor of 22. But when it is, it works really nice. So there's the idea. Use that idea for B and C. Sorry, let me just see if you guys are doing the other one. So I'm saying we're doing the ones on the screen, by the way, just because the ones I feel like the ones on the before were a bit trickier. Ones on your handout are a bit trickier.
Okay. That is what I was doing. I did E and F.
Did E and F? Oh, okay. All right, okay, yeah, nice. Oh, the answers for A and B were E and F. Oh, yeah, they're correct. So I thought you were answering A and B from like, yeah, okay, those two are correct then. So I want you guys to do very similar things as you did for A, for B, and C. You're going to try to cancel the reciprocal away, make it go away, by multiplying by whatever the reciprocal of the reciprocal is. That works as well, yeah. In the next season, the reciprocal is -0.6. They still cancel away. But you get, instead of 1, what do you get? So what's the reciprocal? -1.6.
-6.
Right? So this is just 6, but without a negative sign. Without negative sign, they multiply, you get. What's negative sign positive?
Negative.
6 positive, sorry, positive and negative. It's just 1, but with a negative sign. Right? Because it's negative, positive and negative. The sign doesn't go away. Ends up just being negative. Does that make sense? So they're not exactly reciprocals, but the values of the reciprocals are the same. You gotta be careful. The number's gonna get. First, what you think the number's gonna get small. Because look, it's small. Because you're gonna end up being 9. Does that make sense? A. It's 8 times 9. You split it up in 8 times 9. 8 and 1 and 8 cancel. It becomes smaller. So you're on left with 9. You know, try to use that idea for the same idea. Right? And if you want, you can ignore the negative sign until the end. That's trickier. That's easier. So you got to get this very good. Like, what do you do from there is the question. Because the reason we got that out is cancel it out, right? So you can't cancel that directly. What you can do is see what 6 times what negative 1 is 6. No, the values are going to cancel because it's reciprocals. 8 times 1 on 8 ends up being 1, right? That's the definition. 6 times negative 1 on 6. They're not exactly reciprocals, but they're very close. How are you going with this one? It's a bit tricky at you. Yeah. So you just gotta think. The reason we did that was we found the reciprocal 1 and 8. And with that, so the same thing, yeah, it's a reciprocal of this one. And actually, one thing I'd say for B and C, do the positive multiplication and think of the sign at the end. So ignore the sign at the start. So just do 126 times 1 on 6. And then just whatever your answer you get, you put a negative at the end. There's only one negative. For this one, do 8 times 1 on 8. So sorry, I should, for online people, I should point at it. For part C, what we should do is, sorry, where's my pencil? Again. Sorry guys, give me a second. I lost my pencil. Oh God, how do I do this every time? Too many pockets. Oh, it's in this inside pocket. Alright, so thing I recommend for part B and C is the negative sign is kind of annoying. What I would do is I will ignore the negative sign. I just do 126 times 1 and 6 and do it like I did A. And this one I do 88 times 1 and 8 and figure out the sign at the end, right? Or just leave it on the outside for now, right? Because here this is a positive number for part B. It's a positive number multiplied by a negative number. The overall answer is going to be what? Negative or positive? Negative, because they're not the same sign, the opposite signs. So you figure out the answer, what 126 times 1 on 6 is, put a negative at the end. Or for C, right? What's the answer going to be? Negative times negative. It's going to be positive. So you don't need to change time. This is your answer. These are the same. So you do these two, and it's a lot easier to do this without the negative signs. And then you do this when you answer, and you put the sign at the end if you need to. Does that make sense for those online as well? Hello?
Yes, it makes sense.
Yep. All right. So I think if you do the negative signs, it gets a bit ugly otherwise. Maybe it won't be though. So do like 126 times 1 6 like you did. Okay. So what we're doing is applying a concept. The concept was what we did in A. You can just repeat that concept. It's a tricky concept. So I just want you guys to repeat that concept again. Yes, Sarah, I agree. 5 more minutes.
I sent you my answers.
Okay, yeah, I'll take a look. Well, which one is this? Which questions are there?
F and E. I did it in the wrong order. So the first one is F, the second one is E.
Okay, but it's not going to be a whole number, right? For E and F. So
We
the
do-
value is correct, but it's a fraction.
Oh, so we have to find the entire repeats.
Or the reciprocal of the answer.
Yeah.
No, we're doing a different one now. We're just doing multiplying them together.
Okay, sure.
But the tricky ones are A, B, and C. So focus on those ones first.
Okay, sure.
So send me those ones. I'll see how you want those. So first of all, I just say right 126 and 106. So ignore the negative signs. Negative signs make things too complicated, right? So same thing. I think just get rid of the negative sign and then figure it out the end of the negative sign. Let's do the positive one first. What we did in A was we have 1 and 8. Try to find the reciprocal of 1 and 8, right? And we got that, which was 8. And then split this first number into the reciprocal times something. So reciprocals 1 and 8 was 8. That's 72 split into 8 times something, which is 8 times 9. Do the same thing here. What's the reciprocal of 1 and 6? Or e to negative, positive version. Forgot the put the negative at the end, right? So reciprocal 1 and 6 is 6, right?
Yeah.
You start to split this number into 6 times something, because then to get that you can cancel 6 away. So it's 126 is 6 times something. You can do division if you want. Figure that out. And same thing here. What's the reciprocal of 1 and 8?
8.
8, right? So you try to split the first number into
So like this.
6 times 21 times 1 and 6. So just replace 126 with this. So the next line ends up being 6 times 21. Because 126 is the same as 6 times 21.
So.
No, you just do it. 72, you write it down as 8 times 9. 126, you write it down as 6 times 21. So just replace this 126 with this. Then like the next line of working. But is the answer negative 11 or positive? Right, because it's negative times 8. You still multiply one is still there. Only replace the first number. No times by. Because this the 1 and 6 didn't go away. You replace this with this, they go equal. But the 1 and 6 doesn't go away, still stays there. So like actually I'll explain this here. So I want for A, B, and C, I want 4 number answers.
Okay.
So 126 and 1 and 6. What's the reciprocal of 126? 1 and 6? 6, right? You can split 126 into 6s. You divide by 6. 6 times 2 is 12. 2 and 1, right? It's 6 times 21 times 1 and 6. You write like this. Why do you write like this? Oh, why is it green? You have this. And what we want to do is, the reason we write like this, what can we do here at this step? Once you finish this step, what do you do next? What's the entire point if you're splitting it up like this? What do we do in part A at this point?
Division.
Sorry?
Division.
Not division, but I think you might have the idea. You make it go away. This cancels. They're reciprocals. They multiply together to get to 1. So maybe 1 times 21, which is 21. Right, we can practice this idea and do for C as well. This idea is going to be in the homework question, so it's really important. Arjun, the answers for A and B are good. Oh, but yes, the sign. It's negative 21. I forgot that because there's original negative to begin with, so the answer is negative 21. Right, and C is 88 times 108. Right, and do the same thing again, and you get the answer. So this is probably the tricky concept. So we've run out of time, but if you guys have to leave, it's fine. We'll just quickly discuss C, then we finish that. Right. So what's the reciprocal of 108? 8. I want someone online to help me out with the rest. So the reciprocal of 108 is 8, right? So you got 11. Yeah, you got. Okay, so what do I need to multiply 8 by to get to 88? Someone online, please. I need your help.
11.
11, right? 8 times 11 is 88. Then what do I do here? Right, 8 times 11 times 108. What's my next step here? Please, someone online, please.
No, wait. No, it's not 11. It's
No, it was 11. Right? I think you're correct.
88 times 1 over 8, which is equal to 11.
But we went backwards. But how do you get to 11? What's the step?
8 times 1 over 8.
Becomes?
Maybe
1.
Yeah.
And then we do
This 1. They cancel out to become 1. So reciprocals, right? 1 times 11. So and the answer is 11, like you said, right? Does that make sense for everyone else online as well?
Yep.
So that's the main concept this week. So on the homework, there's going to be a lot of those questions. So you guys need to be comfortable with that, right? All right, we'll finish up there. This last 3, I'll put the answers up. They're not that tricky. It's just fraction multiplication. 14 over 9 for D. For E is 1/6. And for F, it just multiply the denominators. 1 and 5 times 1 and 4. It's 1 and 20. Not that important for our concept. I think our main concept was A, B, and C. All right. We'll finish there. Do you guys have any other questions?
no.
No? All right, we'll finish then. So I recommend, just in summary for these, because it's going to be on your homework a lot. For these type of questions, ignore the sign at the beginning, do the normal multiplication like this, and then don't forget the sign again like I did, right? That's the key idea here. All right, I'll see you guys next week. I hope you guys have a good week. Bye.
Bye.
And you guys do, have you got Alchemist?
Yeah.
Good.
I don't know if my dad did the thing so you could see it.
Okay, I'll send you the link. It's like 1 second here anyway.
Yeah, okay.
Have you been keeping up with Alchemist? Yeah.
But I did.
You did it? That's good. This, I haven't checked fully yet, but you've been doing homework well, so. I'll see you guys next week. And Ima, have you got homework?
Oh, yeah.
You upload online, right? Online. Bye.